Question 2 from your grade 9 MathLinks 9 practice test on chapter 8. It says, what is the solution to the equation of this? Now, in grade 9, I don't know why they did it only in grade 9. But if I take a simpler question and without using decimals have something like this. This should have been a grade 8 question, but they made a grade 9. The first step here is actually really weird because normally we see the variables in our numerator, and we would say, okay, I got to multiply both sides by 2 to get the answer, and x is isolated, and I get 4 as my solution. But when it's in the denominator, I have to multiply both sides by x first, which is kind of counterintuitive because we never actually multiplied by an unknown number. But multiplying and dividing by whatever number it happens to be, regardless of its value, is going to be opposite operations, leaving me with 2 over here. And 4 times x is now 4x. I now have a one-step equation. Divide both sides by, and I have x equals a half. Okay. So when the variable's in your denominator, it really becomes a 2-step equation, even though it looks like a 1-step. So going to this question here, if I take negative 5.2 over t is equal to negative 3.25, my first step is going to be to multiply both sides by t. Okay, that's going to be opposite operations of dividing by t, leaving with just my negative 5.2. And I have negative 3.25 t as my equivalent value. Now I'm going to divide both sides by my coefficient. And t is isolated. And its value is negative 5.2. If I grab my calculator here. So 5.2 divided by 3.25. Notice how I didn't actually use my signs there because I know a negative divided by a negative is positive. So unless you're not very comfortable with that, you don't have to worry about it. And I know my answer is t equals positive 1.6, which means my solution is A. Question 3, what is the solution to this equation? So in this particular one, if I was to give you a simpler version of this and I was to make it very simple, I'm going to put variable term plus 3 is equal to 4x minus 5. This is a simpler version of this particular question. In fact, if I was to make it in the exact same form, I would reverse my constant and coefficient and just keep it like that. And here I would have to go negative 5 plus 4x because I'd have to reverse it to keep the constant, the first term in both expressions. So here, if I think of it as a scale, I think of it as 3 and 2x and negative 5 and 4x. If I think of this equation drawn out, the important part here is if I was to take these 2x's and take these 2x's and remove them, right? Would that affect the balance? And the answer is no, it would not affect the balance. So if we think about what does this then look like numerically instead of graphically, I'll bring this arrow over here too. If I think about what that idea looks numerically, it looks like this. I'm going to subtract 2x from both sides. So when you have variables on both sides, the first thing you need to do is remove the variable on one side by creating 0 pairs. And the confusing part is in grades 8 and 7, we learned to divide by just the coefficient. Now remember, that got rid of not the entire term, that just got rid of the coefficient when we did that. So what we want to be sure is that we're not getting rid of the coefficient, but rather the entire term by adding a 0 pair. And graphically, what it actually looks like is putting negative 2x on both sides, right? Removing 2x, they kind of become these algebraic 0 pairs. You can also think of it just removing 2x too. So equals negative 5 plus 2x. And then we would isolate from there. So given that that's how you would solve it in a much easier version with no decimal coefficients, the same thing holds true. I'm going to take this equation, and we have fractional amounts, so it's very hard to draw it like we did in the last question. But here I have a negative 0.3 g, and here I have a positive 0.2 g. Generally speaking, if you get rid of it on the side that you have the least amount, you're going to leave your coefficient of your equation positive. So that's a general rule, but it's not always followed. So I'm going to add 0.3 g to both sides, okay? If I think about what that does, it's going to maintain balance, right? We're going to keep this balance. But it's going to get rid of that entire term. Leaving with 0.45 is equal to 0.85 plus. And right here, when we have this, you got to go back to chapter 5 when you gathered like terms. since G and G are variables that have the same exponent, they are like terms. And all we have to do is just simply combine my coefficients. So 0.2 and 0.3, when I combine those two, it's going to become 0.5. Now that we have that, we have our variable on one side, so we're going to get rid of everything on this side that is not the variable. We're going to isolate the variable, identify the constant. I'm going to subtract 0.85 from both sides to get rid of the constant. I'm going to have 0.5 G over here. And this is a little bit tricky. I have 45 cents, but I take away 85 cents. That means I have negative 40 cents. And if you don't know that, you can just take your calculator and say 0.45 plus 0.85 negative, right, equals 40 cents, negative 40 cents. And once you have that, divide both sides by your coefficient to get G equals, did I press clear? I did, didn't I? So 0.4 divided by 0.5 equals 0.8. So your answer is G equals 0.8. Going back to multiple choice, my answer is A. Is it positive or negative? I didn't even look. I think it's positive. Oh, no, it's negative. Negative, sorry. Oopsie daisy. Ignore that circle. The answer is B.